Lesson, we're going to learn how to describe scatterplots and associations. So first of all, scatterplot is used to display relationships between two quantitative variables. So you've got to have two, and they have to be quantitative. When you're looking at a scatterplot, there are four things you always must talk about. The first being direction. So the words you'd use to describe direction would be positive, meaning as the x variable increases, so does the y. Negative would be as x increases, y decreases. And then having no possible direction here would just be the points are kind of all over the place and you can't determine it. Next, you talk about the form. And the words you use are either linear, or if you're seeing a curve, it would be nonlinear. Now, rarely are things exactly linear, so you kind of use some descriptive words like fairly linear, moderately linear to help describe it. Then we talk about how strong is that association. The closer the points are together, the stronger it is. As they spread out, we would use a word like moderate or weak. Then you need to talk about unusual features. The things you want to look for here are clusters. Here, obviously, with two different colors, you can see two clear clusters. Outliers, so there's a definite nonlinear trend here. There is one specific point that the predicted y value is very different than the other points. And then here's a set that has no outlier. Now, if you see no unusual features at all, it's always a good idea just to mention that you don't see unusual features to let those who are grading your AP exam know that you know a lot about statistics. So let's put this into practice. So here's an example from your textbook. It says hurricanes develop low pressure at their centers. This pulls in moist air, pumps up their rotation, and generates high winds. Standard sea level pressure is measured around 1,013 millibars or 29.9 inches of mercury. Hurricane Katrina had a central pressure of 920 millibars and sustained winds of 110, that should say knots. So that interestingly would be let's see, if we go over to 920 and up to 110, that's probably about this point right here, would be Hurricane Katrina. Now, here's a scatter plot of maximum wind speeds versus central pressure for 163 hurricanes that have hit the U.S. since 1851. So you kind of think, is Hurricane Katrina all that different than others? Quick glance doesn't really look like it. But when we're told to describe what this plot shows, we need to make sure that we hit all four components. If I go back for just a second, an acronym to help you remember this would be DUFS, D-U-F-S, to make sure you're hitting all your important points. So I see downward trend, meaning it is a negative, moderately strong, linear, fairly linear association. So my statement is there's a moderately strong negative linear association between, now I put it into context, the central pressure and maximum wind speeds. And now I'm going to kind of state what that's saying. So in general, hurricanes with a lower central pressure have higher maximum wind speeds. And then I'm stating there do not appear to be any outliers. Now somebody might make an argument that this point here looks a little bit like an outlier. If you want to make a case for that, talk about that point as an ordered pair when you state it. So I've hit all elements of DUFS. Direction would be the negative. Unusual features down here with outliers. F would be form, which is linear, and then strength, I'm saying moderately strong, and then I have it in context. Okay, you'll also need to be able to talk about the explanatory versus response variable. So explanatory, you've previously known this as your X and response as your Y. But in stat, we say that an explanatory variable is a variable whose values are used to explain or predict corresponding values for the response variable. Okay. So you have two scenarios here. We are, in these two scenarios, going to identify the explanatory and the response variable. So when I read this first one, the weight in carats and the price in dollars for a sample of diamonds, and I think, well, which one could predict the other? So I'm thinking the weight of a diamond ring is going to predict the cost. So I say that the explanatory is the weight and the response is the price. Letter B is not as obvious to me. The SAT score and the SAT evidence-based reading and writing score for a sample of students. I think, Would I want my math score to predict my reading and writing? Or do I want my reading and writing to predict my math? I don't think that's very clear, so I'm going to make the argument that either one could be the explanatory variable because each one could be used to predict or explain the other. Please notice that I am not saying that weight is causing the price of a diamond ring. One is not causing the other. That is something that's very important, and we will talk more about that. We're just saying there seems to be some sort of association between the two. There are many variables that have associations, but there is no causation between the two. Let's look at how to do this now on the scatter plot. So I've given you a list of data. My suggestion is pause the video, enter your data into two lists into the graphing calculator by doing stat edit. When you're ready, hit play again. So I have already entered my data into two lists. I used L1 and L2. I just need to emphasize, make sure that your X and your Y are next to one another in the two lists. Okay, turn your stat plot on by hitting second Y equals. I'm going to choose my first one. It's presently set to a histogram, change it to a scatter plot, and I need to state that L1 and L2 are my X versus my Y, or my explanatory versus my response. Zoom 9 for stat. Zoom stat is your best option here. And if you hit trace, you can see specific points in the scatter plot. As you move your arrow to left and right, it looks like the cursor's just jumping around. The order that it's going through your points is the order that you have them in your two lists. So when I look at this, I'm definitely seeing a fairly linear trend. I'd say moderately strong, and it's negative because as it's going downhill, as X increases, Y decreases. All right, so let's now put this into defs in context. So I'm stating there is a fairly strong negative linear association between the horsepower of a vehicle and the highway gas mileage. And now I'm stating what that means. So in general, higher horsepower is associated with lower gas mileage. Let's look back at that. So in general, higher horsepower, which is my X, is associated with lower, the Y is dropping, lower gas mileage. Final thing I ask you for is to find the correlation. So when you talk correlation, that is a specific number, which we're going to refer to as R in this course. And I will talk more about this in a future lesson. But if you're asked to find that, the graphing calculator will do it for you. We may do it once by hand. And I just need to point out all along, notice I have not been using the word correlation. I've been saying association, and that's important because when you say correlation, that is a specific number that you need to talk about. And perhaps in previous courses, you've used that word a little loosely and you've said correlation when you really meant association, right? To find it on the graphing calculator, might as well show you since you already have all your data in here. What you need to do one time is turn on your diagnostics. So to do that, you go into the catalog, you hit second 0, and that opens up your catalog, and I need to turn on my diagnostic. So a quick way of doing that is if I hit letter D for diagnostic, and it doesn't look like that's going to work for me. There we go. Just scrolls down to the D and I get there quickly. This contains everything in your calculator, so I'm scrolling down till I see diagnostic on, and there it is, and it's just moving up. I want to turn this on, so my arrow's next to that. I hit enter, and then I hit enter again, and it just says done, okay? If you don't run that, you're not going to see your correlation. I won't need to do that again unless I reset my memory or my calculator runs, out of power. Okay, so stat, calc, and you run this option 8, stands for linear regression. Tell the calculator where your data is. It's in L1 and L2. Go down to calculate. We'll talk more about what these things are here, but R, this negative 0.869, which I had on the previous screen is the measure of strength between our two variables. Okay? All right. Please reach out if you have any questions.